Hi children, welcome to my YouTube channel. This is the second video of the video series Static of a Particle, and it's a continuation of the video Static of a Particle 1. Let's try to understand from this example 3. A smooth bead Y is threaded on a light inextensible string. The end of the string are attached to two fixed points X and Z, or from here and here. On the same horizontal level, the bead is held in equilibrium by a horizontal force of magnitude 8 newtons acting parallel to XZ. So in that case, this is a horizontal force. Vertically, the bead Y is vertically below X, where X is at Y. X is at Y. It's 30 degrees. Find the tension in the string and the weight of the bead. Right. Now let's see what are the information where we can mark when we are working out with this kind of a question. The first fact is we can mark the weight downwards. We don't know the weight, therefore I'll just mark it as mg, considering the mass as mg, or you can just mark it as w, because the final answer they ask about weight. Therefore you can mark it as w, right? Then you can understand there's another important point where we have to understand is this is a smooth bead is threaded on a light inextensible string. Okay, so what do you mean by when a smooth bead? When the bead is smooth, you can understand that the tension beside the bead means like the thread has gone through the bead and it has come over here. In this situation, what you can understand is if the bead is smooth, the tension over here and tension over here would be the same. And if the wire is inextensible, the tension throughout the wire does not change. Those are the facts we have to understand, right? With those information, let's try to move up to the answer. Over here, as I mentioned, the tension over here and tension over here should be the same way where we can mark it. Then we will mark the components. Over here, if you work out horizontal component towards the angle component is cos 30. So this component is t cos 30. The vertical component of this one is t sine 30, and this t is the value over here which you can obtain from here. The tension here and here. That means here and here the tension. So the component is t sine 30 plus t over here. Apart from that, I just mark the weight W and force 8 toward this way, which is already here. Right. Okay. Then if you consider the horizontal equilibrium. So in the question, they mention object remain in equilibrium. The bead is held in equilibrium. Therefore, if you consider the horizontal equilibrium, what are the forces? 8 cos 30 must be similar to 8. Or you can write 8 cos 30 minus 8 is equals to 0. Or you can write vertically right hand side forces equals to left hand side forces. Whatever the way you get the same answer. With that, you can say T is equal to 16 root 3 over 3 or 9.34 to 3 significant figures. Then I'll consider the vertical equilibrium. What are the vertical equilibrium components? Then you can say upwards force is equals to downwards force, or you can write the total upwards force equals to 0 since it's in equilibrium. So you can say T plus T sine 30 minus W. Why it's minus W? Because these two forces upwards and I have considered upwards as positive. Minus W equals to 0. Then we know the value for T. T is how much, children? T is 16 root 3 over 3. If you substitute 16 over 3 over 3 and 1 plus sine 30 is half, or you can just substitute 16 root 3 over 3 over here and simplify. Then you will obtain the answer for W as 8 root 3 or 13.9, correct to 3 significant figures. That's a way of getting the answers for the first example, or the example number 3. Right. Let's move to the next example. A mass of 3 kg rests on a surface of a smooth plate. Rest means in equilibrium, which is inclined at an angle of 45 to horizontal. And over here, the smooth plane. If the plane is smooth, there is no frictional force act over it. That's a fact we have to understand from a smooth plane. 45 to horizontal. The mass is attached to a cable which passes a plane along a line the greatest slope and then passes over smooth pulley at the top of the plane. What are the facts we can understand from a smooth pulley? Is that the pulley is smooth. What you can understand is the tension beside the pulley become same. The tension over here and tension over here should be same, right? The cable carries a mass of 1 kilogram freely suspended on the other side. Over here its mass is 1 kilogram. The masses are modeled as a particle and the cable are light inextensible. If the wire is light and inextensible, what you can understand, the tensions over here should be throughout the wire should be same, right? The force P acting on horizontal is 3 kilograms mass and system is in equilibrium. The facts we need to find is the magnitude of P and the normal reaction between the mass and the plane. Then in part C they ask about calculate how you have used the assumption that the pulley is smooth in the calculation. So the simple, I think I have explained this fact. If the pulley is smooth, you can say beside the tensions of the pulley are similar, right? Let's go to the answers, right? Then if you mark the forces over here, you can understand that here the weight is 1g, mass is 1, weight is t, so it should be 1g and upwards is t, right? Then over here, what are the forces? This tension, then this P, this reaction and the weight. Now when you are working out an object on a slant plane, we should work out the forces parallel to the plane and perpendicular to the plane. That is a general way where we consider the components to understand about equilibrium or some kind of dynamic situations even. We will consider the parallel to the plane. Parallel to the plane means along this way and perpendicular to the plane along this way. Right, okay. Let's try to consider the component of 3G. You know that if this angle is 45, here the angle is 45. With that, if you draw a angle here would be 45, right? Obviously, from previous videos, we have already learned how to get the component anyway. If this angle is 45, this angle also turn up to 45 to the perpendicular to the plane line, right? Therefore, this force component into 3g cos 45. This component is 3g cos 45. The parallel to the plane component that become 3g sine 45. That is the components of the weight 3g, right? Okay, we got that one, right? Okay, then this tension I'll keep it as it is over here, T, not a problem. This reaction is somewhere over here, that's the same way. Now we can consider the components of this force P here, right? If this angle is 45, you can see this angle is an alternate angle. If this angle is 45, this angle also how much? This angle also 45. Therefore, this component should be how much? P cos 45. This component is P cos 45 and this component is P sin 45. Then you have to see whether the direction of the arrow. If the direction is the arrow, if you just flatten over here, the arrow goes from bottom to top. Here it's from bottom to top. If you convert towards the normal, what you can do, you have to we have to rotate in a way of forming an acute angle. So if you rotate over here, it's not like that. So you can rotate like this, but it would form up a obtuse angle. But you have to turn up to get the components throughout way of the acute angle. For this way, if you just hold it from this corner and if you pull it away, which way the force goes? It force goes downwards. That is why I just mark downwards P sine 45. That is the way of marking the components over here, right? Initially, we know that object remain in equilibrium. For this system, if you consider the equilibrium, you can say that T is equals to 1g. T is equals to 1 0. Other than that, you can say T minus 1g equals to 0 because it's in equilibrium. Therefore, you can get the answer as T is equals to 1 into G is 9.8. In mechanics, usual figure we are used for G is 9.8. So, T is equals to 9.8. Now, we know the answer for T over here when you are working out the next section of the answers, right? Okay. Then I'll consider the forces along the plane in 3 kilograms over here. So, what are the forces over here? P plus P cos 45 equals to 3G sine 45. Or other than that, you can say T plus p cos 45 minus 3g sin 45 equals to 0. Then we can say p cos 45 equals to 3g sin 45. We know the value for t. What is the value for t? T is 9.8. From here even you can put 9.8 over here. Then you will obtain the answer as p is equals to, if you simplify over here, p cos 45 to 3g sin 45 e minus g. How do you get g came? Because we already found the value for t is g. Then we can say uh, p is equals to 3g sin 45 minus g divided by cos 45. That means this whole thing has been divided over here. This is a simplified answer for this. Don't worry, you just substitute this figure into your calculator. You will obtain the answer over here. So it will get the answer as 16 for two significant figures, right? Then we know the answer for P, right? Okay. Then what can I get? I can get the equilibrium perpendicular to the plane. If you consider the equilibrium perpendicular to the plane, what you can say? R is equals to 6 sine 45 plus 3g cos 45. Or you can say R minus P sine 45 minus 3g cos 45 equals to 0. Now you know the answer for P. P is how much? 16. You can put 16 over here. And if you simplify with this, you'll obtain the answer as R equals to 32. Okay. Nothing to worry about the answer what you gain over here. You have the calculator. You just substitute these figures. P is 16. After that, you just substitute 16 sine 45 plus 3 into 9.8 cos 45. You will definitely obtain the answer like this. So try out by yourself whether you can obtain the same answer. Then the next answer is, with the pulleys, I have already explained this value. The pulley is smooth so that the tension in the strings will be same to both sides of the pulley. Right? I have explained that part of the answer at the beginning of the question. Right? If you come up with this question, right? A picture of mass 5 kilogram is suspended by two light inextensible strings, each inclined to 45 degrees to the horizontal as shown. By modeling the picture as a particle, find the tension in the string when the system is in equilibrium. Right? When you're working out with this question, children, I want to introduce another concept. What you can understand is here, you can understand that this is a symmetrical situation. Here the angle is 45 and here the angle is 45, but and therefore you can mark the tensions over here as same. Here the tension is equal to here the tension. But generally if an object is connected with two strings, the tensions must be different. T1 you can mark it as T1 and T2. But if the system is symmetrical, you can say both. It's like there's a symmetricity over this axis. In that case, you can consider these tensions as similar tensions. And the other condition is if the like if these two angles are different, suppose that this is 45, this is 30. In that case, if there are two strings are there, you cannot say the tensions are similar, right? The other case is if you connected with what you call that two different tensions with two angles, that the tensions are not similar. And if there is symmetricity, you can say the tensions are similar. And the other one is if this is traveling through a smooth condition, just like the question what we did in previous section. If it is a smooth beat, for that condition even we can say, though the angles are different, you can say the tensions are similar if you're traveling through a smooth beat, right? Anyway, the tension here would be same. You can mark it as same. Then if you get the components, right? How do you get the component over here? If this angle is 45, this angle also 45. Therefore, you can mark the tension over here as T cos 45 and T sin 45. Here, T cos 45 and T sin 45, right? From this way, even this tension you can mark T cos 45 and T sin 45. Here, T cos 45 and T sin 45. Then how do you get it? Pretty simple. You can say, if you consider the upwards equilibrium, you can say T sin 45 plus T sin 45 minus 5g equals to 0. Or you can say T sin 45 plus T sin 45 equals to 5g. Upwards equals to downwards. With that, you can obtain the answer over here, because we can say T sin 45 plus T sin 45 is 2 times of T sin 45. With the value for sine 45, you can obtain the answer, and you can consider G value over here as 9.8. That is how you can obtain this answer. Let's move up to the next question. Right. A particle of mass m kilogram is suspended by a single light inextensible string. The string is inclined. So you know that it's light inextensible means what you can say. The tension is unique throughout the string. The string is inclined at an angle of 30 degrees to the vertical, and the other end of the string is attached to the fixed point O over here. Right. Equilibrium is maintained by a horizontal force of 10 newtons. Each act on a particle as shown in the diagram. Find the tension in the string and the value of F. So you can say what are the forces? 10 newton over here, and the weight is downwards mg. And the tension is which way? From here onwards, this side, T. So if you mark over here, you can say that the tension is here. So simply you can get the tension over here. Then if this angle is 30, what is the angle over here? This is T. This is 30, sorry, this is 30. Therefore, here the tension is T. This component would be how much? T cos 30. And this component is T sine 30. Here, T cos 30 and T sine 30. From here, if this angle is 30, this angle is also 30, alternate angles like this. Therefore, T cos 30 and T sine 30. Then if you consider the horizontal equilibrium, 10 is equals to T sine 30. Then you can say T is equals to 10 divided by sine 30, that is 20. Then if you consider the vertical equilibrium, now you know the value for T. T cos 30 equals to mg. Then T is how much? 20. We already found T is equals to 20. Then you can say 20 cos 30 equals to mg. Then you can say m is equals to 20 cos 30 divided by g. G, you can put the value for 9.8. You will obtain the answer as the mass of the object is 1.8 kilograms. Right. Hopefully you can understand how to get that right. Okay. The third question is a particle of weight 12 Newton is suspended by a light inextensible string from fixed point O. The horizontal force 8 Newton is apt on the particle, and the particle remains in equilibrium at an angle of theta. An angle of theta, the vertical. Find the angle theta and tension in the string, right? Let's see how to work out with that. If you consider if this angle is theta, this angle also theta, vertical component. So this one is T cos theta, and this value should be T sin theta. I think I made a mistake. Shall we correct this, right? Okay, this is T cos 30. It should be T sin theta. We will include, yeah, right. Insert simple, and we will put theta here. Yeah, it's over here. Yeah, I'm already using this angle, therefore can get it. Yeah, then okay, and this one also not 30. This should be how much? It should be theta, right? Okay, then that's it, right? Then again, let's back to the question. Yeah, it's T cos 30 and T sin 30, right? Okay. With that, if you consider the horizontal equilibrium, what you can say, AT equals to T sin theta. Yeah. I'll get this as first equation. If you consider the vertical equilibrium, what do you get? T cos theta equals to 12. Now I got two different equations, right? Okay. Then we know that first equation is T sin theta equals to 8. Second equation is T cos theta equals to 12. Right. There are two unknown parameters. Therefore, I'll just divide the first equation by second equation. Then this T and this T get cancels. Sin divided by cos is tan. Therefore, you can say tan theta equals to 3 over 2. Theta become tan inverse 2 over 3. Tan inverse 2 over 3 is how much, children? 33.7. Use your calculator and see whether you can obtain the answer. Remember that your calculator should be in degree mode, since the answer obtained here is in degree mode, right? Then after that, what you can do is we can substitute this 33.7 in our first equation here. Then you can say T sine 33.7 equals to 8, right? Then T is equal to 8 divided by sine 33.7. You can obtain the answer as 14.4 newtons. I hope you can understand the situation and how I obtained this answer in this question, right? The next question is, a particle of a mass 6 kilogram hanging in an equilibrium suspended by two light inextensible strings inclined at 60 and 45 degrees horizontally. Find the tension in each of the string. There are two different strings and two different angles. Therefore, you cannot mark the tensions as similar. because there is no symmetricity and two different strings. Therefore, you can consider the forces as T and S. We need to find the value for T and we need to find the value of S, right? Okay. Then if this angle is 45, we can say this angle also 45. Therefore, the horizontal component is S cos 45 and vertical component upwards is S sin 45. For this way, if this angle is 60, this angle also 60. Therefore, this would be turned up to T cos 60 and this is T sin 60. Here, sin 45 and cos 45, cos and sin, right? And weight. Mass is 6, therefore the weight should be 6g, right? Then if you consider the horizontal equilibrium, right? What you can say? Yeah, horizontal equilibrium, if I get it, uh, yeah, right. Here, horizontal equilibrium, if I get it, you can say, if I go ahead with this one, S cos 45 equals to T cos 60. S cos 60 is equals to T cos 45. Here you can see from this one. This value equals to this value, right? Equals to 0. Or you can say T cos T minus S cos 45 equals to 0. Or you can write T cos 60 equals to S cos 45. With that, cos 60 is half, cos 45 is 1 over root 2. With that, you will obtain this answer and keep it as it is, right? Okay. Then if you consider the vertical equilibrium, what you can say? T sine 60 plus S sine 45 equals to 6g. Okay, or you can say T sine 60 plus S sine 45 minus 6g equals to 0. Here. Then what we can get here is that we can say T sine 60. What is sine 60? Root 3 over 2. S sine 45 is 1 over root 2, brought this 60 to other side. Now we know that T is equals to S root 2. Then instead of this T, I can replace S root 2. S root 2. Then T instead of S, I just put S root 2, root 3 over 2 plus S. I can take this S out. Then it will turn up to S times of this equals to 6. Or if you feel like this what I call the simplification is kind of confusing, you just put S root 2 and simplify over here. What that answer then you get S times of root 2 into root 3 divided by 2 and S into 1 over root 2. Then root 6 divided by 2 plus 1 over root 2. You can add these two and find the answer. Divide 60 by that answer. So you can obtain the answer for S become 30, right? Then we know that T equals to S root 2. So this answer should multiply with how much? S is 30, 30 root 2. With that you can obtain the answer T as this way. Then you can obtain the final answer for this as 43. Hopefully you can understand how to get that value, right? Okay. Let's move to the next question, right? The smooth bead B is threaded on a light inextensible string. The end of the string is attached to two fixed points A and C over here and here. On the smooth horizontal level, same level, the bead is held in equilibrium by the horizontal force of magnitude 2 Newton uh, acting on C towards CA. It's from C to A this side. The section of the string makes an angle of 60 and 30. Horizontal, find the tension in the string and the mass of the bead and state how you have used the modeling assumption that the bead is smooth on your calculation. So if the bead is smooth, what you can get? You can mark the tension beside the bead would be similar. That's the technique I have used. And the mass of the bead is mg. This force is this. Then I'll consider the components here. If this angle is 30, this angle also 30. So this component is T cos 30. Here there should be T. I think I made a mistake. It's missing. So we'll make it kind of correct. Right. Then back to the question. T cos 30. And here this is from here. This is angle 60. This one also 60. So this component become T cos 60 and this will become T sin 60. From here T sin 30. Right. Okay. If you consider the horizontal equilibrium, what you can say? 2 so if I consider T cos 30, if you consider this side T cos 30 minus T cos 60 minus 2 equals to 0. I have considered this side as positive. Therefore, this is plus, these two are negative. Y is equals to 0 since it's in equilibrium. Then you can take this T out. If I take this T out, what is the remaining? Cos 30 minus cos 60 equals to 2. So you can say T is equal to 2 over cos 30 minus cos 60. Then you can put in the calculator and you will obtain the answer for t as 5.46. Don't worry about this, all the simplification. These are the step simplification. You can use your calculator to obtain your final answer. Only thing is that from here to here, what I did was I just wanted to rationalize the denominator. That is why I just multiply with root 3 plus 1 over here. Usually when you're keeping an answer, we will keep the answer in a rationalized denominator. That's what I did over here, right? Other than that, if they ask you the significant answer straightforward, you can put this into your calculator and you can obtain the final answer. Only problem comes if they expect your answer in this format. In that case, after from here to here, we can understand there is no denominator. That means they have rationalized the denominator by multiplying the third conjugate over here, right? That's how you learn it. If you feel like the theory about surge conjugate is hard for you, refer my video related to related to surge. That you will get a clear idea how to rationalize a denominator, right? Okay, then if you consider the vertical equilibrium, what are the vertical forces? T sine 60 plus T sine 30 equals to mg. We know the value for t right now, 5.46 or 2 into root 3 plus 1. So you can say these two addition is equals to this, or you can say t sine 60 plus t sine 30 minus mg equals to 0. Then mg equals to t sine 60 plus sine 30. I just take the t out. And we know the value for t is 2 root 3 plus 1 sine 60 plus sine 30. So here g came over here. G is how much? G is 9.8. Then you can obtain the final answer. They ask about the modeling. What is the assumption we use with the modeling the BD is a smooth object. With that, the tension between, there is no friction. Therefore, the tension would be similar in both sides of the wire. That's the main fact we can consider, right? Okay. Then if you come across this diagram, right, a smooth bead B is threaded at a light inextensible string. At the end of the strings are attached to fixed points A and C. Let's take a bit of correction over here. They need to be nice looking, right? Then the smooth bead B. If the bead is smooth, what you can say? The tension over here and here would be same, right? Okay. And there's a vertical force over here N. The mass is M, therefore the weight is mg. We need to find the tension and the mass of the bead. That's obviously same fact they are looking for. Then if you consider this diagram, what you can see, the tension here is same. So if this angle is 30, this angle also 30, therefore this component is T cos 30 here. And this component is T cos 30. Sorry, T sine 30. This, if this angle is 30, this one is 30, therefore this is T cos 30 and this is T sine 30. So this cos and T sine 30, right? Okay. From this one here, the tension is here. If this angle is 60, this one also 60. Therefore, this is T cos 60. T cos 60 and this side is T sine 60. These are the two forces. These two from this one and these two from this one, right? And 2 is here and the weight of mg is over there, right? Then if you consider the, right, there's also, we will make a little bit correction. This diagram has to be a little bit more, then you get a clear image, right? Okay, right, okay, here. I just copy down this figure over here to understand how to get the component rather than to turn the slides back and forth. That's why I just brought this diagram over here to understand it clearly, right? Okay. Then if you consider the horizontal equilibrium, what you can say, 2 minus t sine 60 minus t sine 30 equals to 0 since it's in equilibrium. Therefore, you can say t, if I take t out from these two, cos 60 plus cos 30 is equals to 2. What I did was I just brought these two terms this side. Therefore, this minus turn up to plus. Then you can get this answer for t as 2 divided by cos 60 plus cos 30. Or if you feel like this is much confusing, you can put this figure into the calculator and obtain the final answer. So t would be 4 over 1 plus root 3. Here also, the objective is I have rationalized the denominator. I have rationalized the denominator. That is why I just multiply with 1 plus root 3 by root 3 minus 1. And you have obtained the answer for 1 plus 4, 6 over here, right? Okay. Then if you consider the vertical equilibrium. Yeah, if you consider the vertical equilibrium, what you can say? T cos 30 minus T cos 60 minus mg equals to 0. Vertical equilibrium, right? Here it's equals to 0. Or you can say T sine 60 minus T cos sine 30 equals to mg. Upwards force equals to downwards force, right? With that, we know the answer for T. What is the answer for T? T is 1.46 or 2 into root 3 minus 1. 2 into root 3 minus 1 sine 60 minus sine 30. Then you can obtain the final. This is just a simplification only. You will obtain the answer as m is 0.055 kilograms. That means 55 grams. That's how you need to obtain the answer according to this question. Right. Then let's move on to this question number 7. Right. When we working out this question, a particle of weight 2 Newton rests on a smooth horizontal surface. There is no friction over here. Remain in equilibrium under the reaction of two external forces P and 1. As shown in this much, they have given the angle is tan theta as 2/5. Right. We know that if you get a right angle triangle, if the tan theta is 2/5, this is opposite over, adjacent is opposite is 12, adjacent is 5. Therefore, if you have this is a Pythagoras triple, therefore hypotenuse should be 30. So with that, you can say this fact from this one. Find the value for P and normal reaction over here. When they are sides contact the surface, there should be a normal reaction, right? Okay. Then normal reaction is here, weight is 2. Here given it's 2 and the horizontal forces. Here you can say P, this component is cos theta, P cos theta, and this component is P sin theta. Now your problem is that how does this P came over here, not this way? So you can say if you hold this end and if you drag it down, which way the arrow goes? Arrow goes to this side. That is why it's to P cos theta. Then vertical component. If I hold this end and if you just hold vertical, then which way it comes? Downwards. That is why it came downwards, right? Then if you consider the horizontal forces, what are the horizontal forces? P cos theta minus 1 equals to 0. Then you can say P is equals to 1 over cos theta. We know the cos theta value, 5 over 30. And you can obtain the answer for 2.6. How do you get this 5 over 30? Draw a right angle triangle and mark this angle as theta. Mark the opposite as 12 and this is 5. If you have the Pythagoras theorem, this is 30. Therefore, this is 5 over 30. That is how it comes, right? Okay. Then we know the value for P is 2.6. Then we convert the vertical equilibrium. R is equals to P sine theta plus 2, or you can say R minus P sine theta minus 2 equals to 0. Now you know the value for P. If you substitute with P, you can obtain the answer for R as 4.4 newtons. That's how you need to obtain the answer for that question. Right. Then let's move on to question number 8. Right. Over here, this is there's a pretty long description, but the question is not that hard. The part A is quite easy, but when you come to part 2, only you have to work out it a little bit further, right? Okay. Let's move to question number 8, part A, right? A mass of M is tested on a smooth horizontal table. The particle is attached by a light inextensible string. If the wire is light and inextensible, the tension is same. Travel through a smooth pulley. If it is the pulley is smooth, the tension beside the pulley becomes same. And then vertically pulley at B, right? Okay. The horizontal force F is applied to maintain in equilibrium. The normal reaction between the table, between A and the table is R over here, right? Okay. Find the value for FR in terms of M, right? Let's go ahead with this, right? We know that here, if you consider the forces over here, the mass is 2 mg and the tension is over here. Therefore, these two forces should be similar. Means what you can say, tension is 2 mg. Here the tension become 2 mg. If this tension is 2 mg, what can you say about the tension over here? This one also 2 mg. Therefore, you can simply say F is how much then? F is equals to 2 mg. 2 mg is how much? 9.8. 9.82 is 19.6 m. They expect you the answer in form of m. Nothing to worry with that, right? Okay. Right. Then there's one reaction. Reaction is obviously similar to mg, vertical equilibrium. So with that 9.8 f, g is 9.8. That's how we came, right? Okay. Now let's see the next part of the question. That is kind of crucial, right? The pulley is now raised over here. I just Hold these pulleys upward. Then what happens? This tension goes somewhere like this and then falls down. Position between the edge and the table so that the string is increased to 30 degrees. So it forms an angle of 30 over here. The horizontal between A and the pulley. Now the string hang vertically between pulley B, the horizontal force of F dash. So now this force is turned on to F dash and apply the equilibrium new situation, the normal reaction between A and the table. A and the table become R dash. Now this is not R to turn up to R dash. Find in terms of M the value of F dash and R the same way what you did over here. If this pulley is little bit smooth and so a little bit lifted up and therefore it forms an angle over here as 30. That's a question. Let's try to understand. Right. Okay. Here. Then if you hold this from a 30 degrees, you can get two components. What are the two components? T dash cos 30 and T dash sin 30. That's the only difference where we can come across. Other facts are same. P sin here, the value is not P sin theta, it should be mg. I think I made a mistake here. It should be not P sin theta, it should be mg, right? Right. Okay, let's back to the question. Right. It's mg. Therefore, you can say r dash plus, if you consider the vertical equilibrium, r dash plus t dash sine 30 is equals to mg. Right. Okay. Then how can we get this value? Yes, we know the value for now. We need to find out r dash plus t dash equals to t dash sine t equals to mg. From there, it's a doubt over here. Then horizontal equilibrium is t dash cos 30 equals to f dash. But here still there are two unknowns. Then we can consider the equilibrium of this particle. Then what you can say? T dash is equals to mg because this is in equilibrium. So there is no other forces. T dash equals to 2mg. Sorry, t dash equals to 2mg. Here. From here you can get the value for T dash. Now I know the value for T dash is how much? 2 mg, right? Then we can consider the horizontal equilibrium over this object. T dash cos 30 equals to F dash. T dash cos 30 equals to F dash. What is T dash? Is 2 mg. 2 mg cos 30. 2 mg, what is cos 30? Root 3 over 2 equals to F dash. With that you can obtain the answer for F dash, right? Okay, root 3 mg again. We have substitute the g value as 9.8. You can obtain the answer over here, right? Then the reaction. How to get the reaction? R dash plus t sine 30 equals to mg. R dash t sine 30 minus mg equals to 0. Then we know the value for t dash because what is the value for t dash? 2 mg. So if you substitute mg minus t dash is 2 mg, sine 30 is half. If you work out what you can obtain, is another critical situation, r dash becomes 0. That means this object is just about to lift from the surface. That is what you do it. If you just do it little bit, if you apply little bit force further, what happens? This object will definitely jump up from the surface and the contact won't be there further. Here itself, it's just at a limiting equilibrium. Right? Okay. If you come up with this question, this is not a very hard question. The particle of mass 2 kilograms, 2 kilograms, therefore the weight is 2g. Then you can consider the components. If this angle is 45, this component become 2g cos 45. This value become 2g sine 45 from the components, right? I just mark it. P is over here and reaction over here. We need to find the value for P. So simply what you can get the equilibrium along the plane. P is equal to 2g sine 45 since it's a smooth surface. With that, simply you can obtain the answer as P is equals to 14 newtons, right? How I did was P is equals to 2g sine 45 to 9.8 sine 45 is 1 over root 2. With that, you can get the final answer as shown in the in this sheet, right? Okay. The question number 10. Now it has made a little bit of a what you call complex prior to the last question. The particle of mass 4 kg. So the 4g is here. So the weight component is 4g cos 45 and this is 4g sine 45, right? Okay. Then this component of P. So if this angle is 45, this angle also 45. Therefore what happened? This force turn up into P cos 45 and this force turn up to P sine 45. These are the components of P. How it came? If this angle is 45, This angle also 45. Therefore, if you consider this side, it should be P cos 45. This side it would be P sin 45. Then I will consider the forces along the plane. 4g sine 45 is equals to P cos 45. Other than that, you can say P cos 45 equals to 4g sine 45. With that, you can obtain the answer as P is equals to 4g sine 45 divided by cos 45. That is 4g. You just put in the calculator. You will, if you are much familiar with these figures, you know that sine 45 and cos 45 are same figures, 1 over root 2. They are with that cancel. Other than that, if you're confusing, just don't worry about that. You just put in the calculator and you will obtain the same answer as shown over here. Right. Okay. Then when you come up with this question, this is kind of little bit advanced compared to the previous question, right? Okay. The weight of 20 newtons. So the weight is 20. Then you can consider this angle is 45. This is 20 cos 45 and this is 20 sin 45. Then I'll mark the components of P. P cos 30 and P sin 30 here. P cos 30 and P sin 30. Cos 30 and sin 30. From here we know that these two are alternate angle. This is 45. Therefore this component is P cos 45 and this is P sin 45. Sorry, 5 cos 45 and 5 sin 35. Here 5 cos 45 and 5 sin 45. Right. Okay. Now they want the value for P and R. Hopefully, yeah. We need to find the magnitude of the normal reaction and the value for P. Right. Okay. Then if you consider the forces along the plane, sorry, forces along the plane, what are the forces? P cos 30 is if equals to 5 sin 5 cos 45 plus 20 sin 45, or you can say P cos 30 minus 5 cos 45 minus 20 sin 45 is equals to 0. I think that's the way they got it. Then we know that cos 30, so you can say I can plot this to this side. That is 5 cos 45 plus 20 sin 45, then divide by cos 30, then cos 45, you can put it in the calculator and you can obtain the answer over here. Then I'll consider the forces perpendicular to the surface. What are the forces perpendicular to the surface? 5 sin 45 plus R plus P sin 30 equals to 20 cos 45. There are three forces upwards and one force downwards. Here you can get the like that equals to 0. Then we know the value for P, and 5 is obvious figure, 20 also there, and sin 30, sin 45 and cos 45 figures we know. So if you substitute over here, you will obtain the answer R as 0.4. Correct to three significant figures. Don't worry about this calculation. So you have a calculator, put this 20 cos 45, 5 sin 45, and P value we already know 20.4, or you can put this one. If you substitute this one, you get a better answer, sin 30. And you can obtain the final answer as shown over here. So that is the end of this session. Then hopefully you can understand how to find the answers for the question which is up in this video. Hopefully you have understood these sections. If you like this video, the thumbs up and share this video with your friends. And to see more educational videos, please click on the bell icon to see more notifications and subscribe my channel to see more educational videos. Thank you and see you from next videos.